Terry again. Today we're going to start on a little different adventure. We're going to be talking about decimals. And if you will remember again what we've learned before, that there are patterns in math. And when you look for the patterns, sometimes you find out that you know things that maybe you didn't realize you did know, or you have enough information at least to figure it out. We're going to do a bit of a review first to help remind you of what you do know. If I write this number, 15,732, we know the 2 is in the ones place, the 3 is in the tens place, the 7 is in the hundreds place, the 5 is in the thousands place, and the 1 is in the 10,000ths place. Now we don't say that when we deal with a number like this. We say 15,732. But the idea is, if we know what those places are, so we know what the numbers mean, then I know this is 1 10,000, 5 thousands, 7 hundreds, 3 tens, and 2. Now, let's look for the pattern. We've talked about this before, hopefully you'll remember. This place here is ones, tens, hundreds, thousands, 10,000s. So as we move from the right over here to the left, for each place, if we multiply this place number by 10, we get the next place number. So 1 times 10 is tens, and that's the tens place. 10 times 10 is the hundreds place. 100 times 10 is the thousands place. 1,000 times 10 is the 10,000s. And can you know how to project now to what the next one's going to be after that? Okay, 100,000s. All right, now let's go in the opposite direction. We're going to start here. This is 10,000. What do we do to 10,000 to get to 1,000? You see that it's dividing by 10? Now, should that be surprising to us? No, because we know that multiplication and division are opposites. They're inverses. They do the opposite thing. So if I start here, I divide by 10 to get here, divide by 10 thousands to get hundreds, divide by hundreds to get tens, divide by tens to get ones. Okay, so that's kind of what we're thinking about here. I hope you're clear on that. Now, one thing I hope you know, maybe you don't. There is a decimal with this number. A decimal. Now, there's also a plus sign there. You don't see it because we don't write it when we know it's plus, because everybody just understands that it is plus. Same kind of thing is true with the decimal. There is a decimal right here. See, if I wrote a 0 after here, you can see that that doesn't change the value of that number, but it actually lets us see that there could be something there. Okay, so now that we can, let me say this right, so that we can understand now how this pattern works. Divide by 10, divide by 10, divide by 10, divide by 10, divide by 10. Is there any reason to think that that wouldn't just continue? Okay, this is the ones place. If I divide it by 10, you might not think about it, but I'm going to write it so that you can see and you tell me what we get. I've got the ones place divided by the tens place, by a 10. Tell me what that fraction there says. Okay, that's 1/10. Remember how we name them? 1/10. So, if I put couple, let's just put here a couple of numbers. Let's say I have 463. Well, this we just discovered is the 10th place. What would be the next place? Well, you might guess, if you were comfortable with the pattern the other way, you might guess it now, but if you're not sure, let's see what happens. What we do, remember, as we're going to the right, we divide each place by 10. So what I'm going to do to get the next place is I'm going to divide that by 10. Only, I'm going to write it 10 over 1 because remember, when you're dealing with fractions, if you make everything look like a fraction, it makes it a little bit clearer for your brain to know what to do. So here's where we are now. 1/10 divided by 10. And what do we do when we divide fractions? Flipping times, dude. Remember, we flip this number over and we multiply. Okay, now we've only got ones in the numerator, so there isn't anything we can do to reduce here. So let's just do now what we do when we multiply fractions. The numerator times the numerator equals the numerator. The denominator times the denominator equals the denominator. Okay, so 1 times 1 equals 1. 10 times 10 equals 100. Okay, this was the 10th place. This then is the 100th place. Now let's just review real quickly. Ones, tens, hundreds, thousands, 10,000s. Here's the important character right here. 1 is the number that the ones place is where we make our notations from. So we got here at the ones. This was 1/10. This was 100th. What's going to be the next one? 1,000ths. What will be the next one? 1/10,000th. 100,000th. 1,000,000th. Exactly the same kind of pattern we had going to the left, except now each one of these places represents something that's less than 1. So now we have to remember to put that THS on the end of the place name. So it's tenths, hundredths, thousandths, 10,000ths, and so on. So if you've got this idea of patterns down, then you're going to know that you can do exactly the same kind of thing you did going to the left, except now we're going to the right, and because of that, we're going to have that THS on the name of it. So you already know a lot of that stuff, and that's good. So let's see where we go from here. Let's take this number, 7,513. Let's review. Let's write it in expanded form. Remember, the word expand means stretch it out, make it bigger. And remember, I hope that you've got this clear, that this is the abbreviated form. We learned the expanded form so we're a little more clear on what this number actually means. So what would that digit, well, let's start here. What would this digit then stand for? Well, ones, tens, hundreds, thousands. It's the thousands place, but because of the 7, what do we have? 7,000. And the 5 would represent 500. The 1 would represent 110 or 10. And the 3 would represent 3 ones. And remember what we had to do to make these numbers that we have here be the same as that one. Okay, we had to add them together. Now we say 7,513, but we learned this so that we're clear when we look at this number exactly what it means. Now, do you think this whole idea is going to change simply because I add some more things here? Let's say I add those three numbers to the right of the decimal so that now I have 3 decimal places. Each one of this is a place. What is that 6 going to represent? It's the 10th place. There are 6 of them, so it's 6/10. And we'll just write that. The 2 is going to represent 2/100. And the 3 is going to represent 3/1000. And so just like we did over here, what we're going to do is just put plus signs in there. Because I've got this number, 7,513, and to that I'm going to add 6/10, 2/100, and 3/1000 to get my complete number. So remember again, it's the same thing. We learn to look at it this way so it'll be a little clearer to our brains what this number actually represents. And if I were going to say this number, it would be 7,513 and 6. Well, let's not deal with that just now, because I don't know if we know for sure how to say that. That might sound a little complicated with what we've got here. So let's just talk about what we would do. We'll take some examples and we'll see what we get, and then we'll see if we can generalize. Now if I have this number here, what is that number? 5 and 4/10, because it's in the tenths place. What would this one be? Well, it's 5 and it's 4, but now this 4 is 4/100, so this one would be 5 and 4/100. One more. Still 5 and, but now our 4 is 4/1000. So they all have the same digits, just the extra zeros make the decimal place different, and so we have to say it differently. But what we need to kind of generalize from that is if we have something like this. Because based on what we've talked about here, that might be a little confusing. Is this 3 and 6/10, 4/100? That sounds a little awkward. So let's see exactly what it was. Now one thing you know in math, when you go from one, or you go something new, you'll always go back to what you know to represent it. So in expanded form, that one would be 3 plus 6/10 plus 4/100. Remember how we did it? You see that that would be the case? Okay, now we've got some fractions here, and we want to simplify this, make it as simple as we can, and we can do that if we add these fractions together. Unfortunately, right now we can't add them because they're not the same. So we look for a number that 100 and 10 will both go into. Can you see that that number is 100? Okay, so we've got to turn this 10 into 100. We do that by multiplying by 10. But remember, anytime you do something to the denominator, you got to do exactly the same thing to the numerator. So we multiply the numerator by 10. So now what we've got is 3 plus 60 over 100 plus 4 over 100. Now those two are the same, so we can add them. And we will get 3 and 64/100. 3 and 6400ths. Well, let's look at this decimal that we've got here. This is the one we're talking about right now. And see if we can see how that works. Okay, there's the 3. There's the 64. Where does the hundredths come from? Because we said over here, we can see that it is 3 and 6400ths. Where will the hundredths part of that name come from? Okay, right there where that 4 is. The 4 is in the hundredths place. So here's how we name decimals. We just say the number that's behind the decimal place, to the right of the decimal place. We just say that number, whatever it is. And the name is found by the last digit in that number. So here we had 3 and 64, hundredths. Okay, so let's just look at a couple of examples to make sure we're clear on this. Let's say we've got 0.832. There's nothing over here, so we don't have to worry about that part, but you just say the number, 832. To get the name of it, you just count over here and make sure you know what that place is. The decimal place of the last digit. So this is 832 thousandths. 832 thousandths. If I had something like this, that number is 5 and 4,689 tenths, hundredths, thousandths, 10 thousandths. 4,689 10,000ths, and that's how we would say that name. And so it's really important that we be able to do this. We're going to talk about some more things we do with fractions and decimals, interactions, and other things about decimals. But this has taken a little bit extra time, so we'll want to do that separately, and then we'll move on to operations that we do with decimals. So take some time and make sure you're clear on decimal names, what they are, how you find them. Get clear on them. Listen to what you're saying when you say it, because we're going to talk about connections between fractions and decimals. And if you understand that, you'll be able to do it. You won't have any problem. So, see you next time when we talk about those kinds of things I just mentioned. Glad to have you come. Hope you come back.